So we're starting with hemostasis, and what is it all about? Hemostasis is about stopping bleeding. Okay, so if your vessel gets ruptured, you want to stop it. Okay, but you don't want to stop it too much, because if you would stop it too much, or I mean, if the thrombus formation would be like delocalized, you would die immediately. So there has to be a equilibrium between a forces, or let's say mechanisms, which makes you clot, and mechanisms which stops the clotting and actually localize the clotting. So on one side, there has to be a good interplay of what? Of vessels. So vessels, I should make it bigger. Vessels, what else? Thrombocytes, and 3 coagulation cascade. But you would die. So there's a seesaw, and on the other side you have all the anti-thrombus formation mechanisms. So that would be what? Anti-adhesion, anti-activation, anti-aggregation, anti-coagulation, and still, so these are the ones which sort of slow down the process which is clotting. And still one more. There's one more break. If you still clot too much, you still have one break. Or let's say you can have a, what do you call it, reverse drive, which is fibrinolysis. Very good. Fibrinolysis. Okay. So first we're going to go we're going to do this part, and then I'm going to jump to this one. Okay. So first, and yeah, vessels were okay. That's pretty obvious. So when there is something, but if we have a trauma or whatever, and you're bleeding, of course, what is the response of a vessel? Vasoconstriction. Okay. And then later there's vasodilation, and you all know that. Basically, very small bleeds can be like stopped by only vasoconstriction. But okay, that's pretty simple. So those were vessels, but now von Willebrand factor, and I will stress the important stuff. What things? Basically, I'm now stressing the things which, if you will remember now, you will use it in the pathology section, and basically you will figure out all the possible diseases we have. Okay, so remember these let's say points, and it's going to be very easy for you to follow the disorders. Okay, so von Willebrand's factor, it's made by what? Endothelial cells, basically many cells produce it, but mainly endothelial cells or thrombocytes, for example. Okay, what is it good for? And there are 2 main functions, or maybe 3 actually, and many other, but 3 main you have to remember. And first is adhesion. It is crucial for adhesion, for thrombocyte adhesion. Okay, so adhesion. I don't have to write it down. Adhesion, or should I write it? I don't know. Adhesion. What else? Aggregation of the thrombocytes. What else? Protection of something. It protects something which is in the blood, and not the tissue factor, but very good. Factor 8. Please remember from today. It's crucial for today and for diagnosis, and whether it's for hematology, for your life, for your medical life. Von Willebrand is floating the idea is it's floating in the blood. There's factor 8 as well, but if there wouldn't be a factor, let's say von Willebrand works as a protector of factor 8. And if you don't have enough of von Willebrand, which is von Willebrand's disease, then also your levels of factor 8 are decreased. So you can have something like sort of like hemophilia. Okay? Yeah? So remember, it's a very important protector of factor 8.
Can you explain what you mean by protector?
It's like a chaperone. Somehow it packs it. Normally, if you put the factor 8 into the plasma, it's cleaved by enzyme, and this protects it from the enzyme. Okay. So but just remember, it protects it. Okay. And last, maybe important thing is, it's a therapy. You know, there's a drug which actually is able to boost up from your endothelial stores, because von Willebrand it's stored in endothelium and under the endothelia, and you can boost up and like squeeze it out of the vessels into the lumen. And it's desmopressin. What is desmopressin? It's ADH analog. And we are using this ADH, it's ADH, but we're using it to boost up von Willebrand and also factor 8. Okay? So remember this, desmopressin. Desmopressin. So that's enough for von Willebrand. We're going to, of course, talk about it again. So von Willebrand's factor, thrombocytes. So on thrombocytes, there are some important receptors you have to know. And what is the idea? There are three terms, and it's like this. So if there's a lesion to a wall, then thrombocyte first adheres, then it's activated, and then aggregates with the other ones. Okay? Activation means what? It means release of many important molecules which force the aggregation and also have the adhesion as well. And also they're changing the shape. Instead of let's say a small ball, they're like a hedgehog or something like a sea hedgehog. What do you call it? Sea urchin. They could look like a sea urchin, but they have very let's say those are not spikes. They're like like very flexible spikes. Okay, which are let's say sticky. So it changes from normal thrombocytes to activated one, which has many hands around it. Okay, and basically adhesion, activation, aggregation, it starts almost at the same time. Okay, but what are the receptors? And I know it's really hard to remember receptors, but it's crucial for today because we're gonna talk about some diseases of these receptors. So, but I will mention a few. So what receptors on thrombocytes? So adhesion. For adhesion, what are important? There are many. I'm sure you learned many in physiology. 2B3A is aggregation. GP1B. Very good. GP1B. So GP1B is crucial for adhesion, and it binds. You know what? If these are endothelial cells, here's a breakage, and actually, what are they using? They're using von Willebrand's factor, which is bound to collagen, for adhesion. This is the receptor, 1B. Okay, so this is a thrombocyte, but it uses von Willebrand's for adhesion. So it's a immobilized von Willebrand's on the collagen, bound to collagen. So this is the function of von Willebrand. It uses 1B receptor to adhere. Okay. There are some other receptors, but mainly you should remember this one. There is also 1A that uses only collagen. It needs only collagen. And when it is bound, it also activates the thrombocyte, okay? And there's also 6, GP6, forget these. Remember 1B. Then there are crucial, or let's say one receptor crucial for aggregation, and you heard it already, it's 2B3. Okay. So this one does aggregation. So it sticks them together. Okay. So this is 2B3A. And what does it use it to stick it?
Thromboxane?
I'm sorry?
Thromboxane?
No. That would be thromboxane is again activation. You're very good with the activation, but it uses, would you believe it, fibrinogen, and also von Willebrand's factor again. Okay, so basically, this receptor uses. You can remember these two molecules which you use to stick two thrombocytes together. Either fibrinogen, not fibrin, but fibrinogen, the whole molecule, still not clear, and a von Willebrand's factor. Okay, and then, as you said very well, there are some receptors important for activation. Okay. So they activate the thrombocytes. And you know there are many molecules which can activate it. Actually, many of these molecules are self-produced by the thrombocytes. So many of, like for example, ADP. ADP is secreted from thrombocytes and it works in autocrine and paracrine fashion. So activates itself and it activates thrombocytes which are very nearby. Okay? So, and the receptor for ADP is P2Y12. Okay, so remember this one. And there are other molecules which activate it. So what could be another one? You said thromboxane, that's very good. So thromboxane is produced, the production takes place on thrombocytes, on the membranes, okay, from the arachidonic acid. Through what enzyme? COX. So thromboxane A2 through COX1 and 2, but one is more important in thrombocytes. so COX-1, and activates the platelets again. It does what else with vessels? Thromboxane does vasoconstriction as well. Okay. So, and what drug blocks the COX-1 actually? Aspirin. Very good. Aspirin blocks it. Blocks. Would you know some other molecules which activate? I'll tell you, thrombin. Thrombin itself, and we'll talk about thrombin a lot. And remember, thrombin is the main player in coagulation, and it's a very important player in activation of the thrombocytes as well. Okay, so thrombin, and it has a thrombin receptor. It's called PAR1, and it is as well on the membrane of the thrombocyte. So this was activation. Okay, so at least remember ADP mostly. Okay, ADP important. So that was adhesion, aggregation, and activation. Okay? Yep. Clear? So this was to thrombocytes. And now let's get to coagulation cascade. So, thanks for watching. And don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.